Hi, and welcome to Ellery Math Notebooks video, Is it a function? In today's lesson, we're asking the question, is it a function? Before we find out whether or not it is a function, we have to learn what a function is. A function is a relationship between inputs and outputs. In this relationship, to be a function, each input has to have exactly one output. Think of a function like a soda machine. If you push a button, you expect to get the same thing every time. So if you push the button for Dr. Pepper, you expect to get a Dr. Pepper every time. The button you push is an input, and what you get is an output. Functions work in a similar manner, with an input and an output. But what if you pushed the Dr. Pepper and you got something else each time? You would assume that someone either messed up filling up the machine or that the machine was broken, right? Functions are very similar. For every input, which is an x value, there needs to be one output, or y value. So if we look at the two examples below, first, on the left, changing the input can give a different output, but using the same input needs to keep the same output. So you see, the input of 3 gives me a 4, but then the input of 5 gives me a 7, and that's okay. Different inputs can have different outputs. But if you input a 3 again, you should always get that 4. However, now if we look at the example on the right, the same input was given each time. Every time the input was a 3, but the output was different every time. So if we hit a 3 and get a 4, hit 3 again, get a 7, use 3 again, get a 9. That does not work. That is not a function. The example on the left is a function. The x value, the input, repeated, but the output stayed the same. When you have the input repeat with a different output, it is not a function. So the example on the right, not a function. Looking at some tables here, to be a function, the input can only have one output. X is the input, Y is the output. So when we look at the tables, we're looking for X values that repeat. Look at the table on the left. Do you see any X values that repeat? How about on the table on the right? Do any of the X values repeat? The table on the left has 2 4s as X values. None of the X values to the table on the right repeat. And when you look at the 4s on the table to the left, you see an output as a 2 and an output as a 5. Because the X values repeated with different outputs, the table on the left is not a function. The table to the right, without the X values repeating, is a function. If the X values don't repeat, you have a function. Inputs cannot repeat with different outputs. Let's have you try a couple. Look at these tables. Decide which ones are functions or which ones are not. Pay attention to the X values. Have you decided which ones are functions? The left and the middle table are functions. None of the X values repeated. In the table to the right, the X value of -1 was seen twice. Each time it had a different output. First time the output was 5, second time the output was -2. That means it is not a function. Were you correct in looking at it? Now, let's try it with ordered pairs. When we look at ordered pairs, you're looking at the same thing. You're looking for repeating x values. So we got three groups here. Determine if each group is a function or not. Again, pay attention to your x values. Have you decided which ones are functions or which ones are not? Let's check. The first example, first group of ordered pairs, is a function. You see x values of 3, 5, 8, 2, and 7. So the x values do not repeat. That means it is a function. You might notice that the two y values, 4, repeat, and 9 repeat. Y values are allowed to repeat in a function. If we look at the second example, you see the x value of 6 repeated twice. The first time, 6, 9, and the second time, 6, 7. X values cannot repeat with different y values. So that makes that one not a function. And in the third example, you see the x value of -1 repeated. First time, -1, 0, and the second time, -1, -2. Again, if the x values repeat, you need to have the same y value. Otherwise, it will not be a function. So, were you correct? Hopefully this has made things a little bit clearer in understanding whether or not something is a function.